In February 1990, from more than 6 billion kilometers away, a spacecraft already racing toward interstellar darkness turned its cameras back toward home for one final look and captured images that stopped the world cold. Not dramatic close-ups of raging storms or hidden oceans, but something far more shattering. Our entire solar system reduced to scattered points of light, with Earth itself nothing more than a single pale blue pixel suspended inside a faint ray of sunlight. These were the last photographs Voyager 1 would ever take, the only complete family portrait of our cosmic neighborhood ever assembled by a machine leaving it behind forever. In that single mosaic of 60 frames lay a truth so raw, so humbling, that millions paused mid-breath the moment the pictures reached Earth months later. Everything we had built, every war fought, every dream dreamed, existed on that infinitesimal speck. And the world has never quite recovered. Voyager 1 was never meant to deliver such a farewell. When it left Earth in 1977, the plan was modest. Race to Jupiter and Saturn, skim their atmospheres and rings, then vanish into history. No one spoke of final portraits or leaving the solar system. Yet a rare alignment of the outer planets, occurring once every 175 years, handed the mission an unexpected ticket to the Grand Tour. Gravity assists would slingshot the craft from world to world with almost no extra fuel, turning a short reconnaissance into something boundless. Voyager 1 launched second, but overtook its twin within weeks, already writing its own faster, bolder story. 13 days out, it looked back and photographed Earth and the Moon together from 11 million kilometers away, our first family portrait from deep space, a blue marble and its gray companion hanging together in the void like children waving goodbye. As it closed on Jupiter in 1979, the spacecraft met a planet that dismantled every expectation. Violent belts of radiation, storms large enough to swallow Earth whole, and a miniature solar system of moons orbiting in chaotic harmony. Thin rings appeared where none had been predicted. New moons materialized in the images. The great red spot revealed itself as a counterclockwise monster, a storm older than human civilization. But the greatest shock came from the moons themselves. One small world blazed with active volcanoes, sulfur fountains erupting hundreds of kilometers high, the first extraterrestrial volcanism ever witnessed. Another showed a cracked ice shell hinting at a global ocean beneath. Liquid water kept warm by tidal forces in a place sunlight barely reached. In days, Jupiter transformed from a distant gas giant into a living, breathing system full of surprises. Saturn followed in 1980, even more complex than imagined. What looked like simple, elegant rings from Earth exploded into thousands of braided strands, dynamic, shepherded by tiny moons, alive with spoke-like features that appeared and vanished. New worlds emerged in the images, one of them scarred by a crater so enormous it made the Moon resemble a distant Death Star. The crowning encounter was with Titan, the only moon in the solar system wrapped in a thick nitrogen atmosphere. Voyager 1 could not pierce the haze to see the surface, yet its instruments revealed chemistry so rich that methane played the role water does on Earth, cycling between solid, liquid, and gas at frigid temperatures. Lakes, rivers, rain, all possible far from the sun. That close flyby came at a steep price. Saturn's gravity bent the trajectory sharply upward, flinging Voyager 1 out of the ecliptic plane and forever beyond the reach of Uranus or Neptune. The planetary tour ended there, but in exchange, the spacecraft gained something priceless. A clear, high-speed path into the unknown, aimed straight at the edge of the sun's domain. For the next decade, it coasted outward in silence, instruments mostly quiet, power levels dropping year by year. By early 1990, it had crossed the orbit of Neptune and was preparing to shut down its cameras permanently to conserve every precious watt. Yet a simple but audacious command was sent. Turn around, warm the optics after years of freezing cold, and take one last look at everything left behind. The risk was real. The narrow-angle camera had to slew across vast angles while the spacecraft moved at nearly 60,000 kilometers per hour. Exposures had to be timed perfectly, or motion would smear the faint targets into useless streaks. For 3 hours the cameras were gently heated, then the sequence began. First Neptune, then Uranus, Saturn, a quick pass near Mars that yielded nothing visible, the brilliant Sun itself, Jupiter, Earth, and finally Venus. 60 frames in total, each one a narrow slice of the sky. Data trickled back across 4 separate communication passes, finally arriving complete on May 1st, 1990. The cameras were switched off at 5:22 Greenwich Mean Time on February 14th and have never awakened again. When the mosaic was assembled, the effect was immediate and devastating. 6 planets appeared as tiny crescents or dots against the black. The Sun dominated one frame, surrounded by diffraction spikes caused by the camera's optics, looking more like a star than our familiar daytime ruler. Jupiter and Saturn still showed hints of their banded atmospheres even at that distance. Uranus and Neptune stretched slightly from the spacecraft's motion during the 15-second exposures. But it was Earth that commanded every gaze. A single pixel, pale blue, caught in a scattered ray of sunlight, like a mote of dust floating in a sunbeam. From Voyager 1's perspective, our world measured less than 1/1200th of a pixel across. All of human history, every city, every ocean, every person who had ever drawn breath, compressed into that fragile point of color. The image did not just show distance. It showed perspective. It showed vulnerability. It showed unity. In newsrooms, lecture halls, and living rooms across the planet, conversations halted. Governments issued statements. Scientists and artists alike found themselves at a loss for words that could match the quiet power of that single blue speck. The family portrait was never intended as science. It was a parting gift, a deliberate act of reflection at the moment of departure. Yet its scientific value proved immense in ways no one predicted. It provided the first calibrated view of how planets appear from interstellar distances, data still used to interpret exoplanet observations today. It demonstrated that even the brightest worlds become nearly invisible beyond the outer solar system, teaching us how rare and precious any detection of distant Earth-like planets will be. Most of all, it delivered an irrefutable visual proof of our isolation and our togetherness. There is only one pale blue dot in that frame. There are no borders visible, no flags, no divisions. Just one world carrying every story we have ever told. After the cameras went dark, Voyager 1 pressed onward into the deepening night. Years turned into decades. In 2012, it crossed an invisible threshold where solar particles abruptly dropped and galactic cosmic rays surged. The first human-made object to enter interstellar space. The heliopause proved sharper than anyone expected. A sudden membrane rather than a gradual fade. Beyond it, the spacecraft detected a persistent plasma hum at 3 kilohertz, the sound of interstellar space itself vibrating, lasting nearly 3 years. The galactic magnetic field pressed against the Sun's bubble with 10 times the expected force, compressing our entire heliosphere into a tighter, more resilient shield. Data revealed that our solar system drifts inside a vast local bubble, a cavity hundreds of light years wide, carved by ancient supernovae, offering unexpected protection from denser interstellar clouds. None of this was visible, yet every measurement carried the same emotional weight as those final images. Space is not empty. It has texture, pressure, and quiet music. The spacecraft itself should have failed long ago. Its computers hold less memory than a modern wristwatch. Its transmitter broadcasts with the power of a refrigerator light bulb. Its power sources, 3 radioisotope generators fueled by decaying plutonium, lose 4 watts every year. Engineers have methodically shut down non-essential systems to stretch the remaining electricity. In early 2025, the cosmic ray subsystem was powered off. By late 2026, the low-energy charged particle instrument will follow. Only the magnetometer and plasma wave subsystem will remain, listening to the interstellar wind as the craft hurtles toward a new milestone. In November 2026, Voyager 1 will reach 1 light day from Earth, the first human object ever to travel so far that a radio signal takes a full 24 hours to arrive. Round-trip commands will require 2 full days. The distance will be roughly 25.9 billion kilometers. At that point, every heartbeat of data will feel like a message from another age. Yet even as instruments fall silent one by one, the memory of those final images grows sharper. They are the last visual evidence we will ever possess of our solar system seen from outside. No future probe is currently funded to repeat the feat at greater distances. New Horizons may one day look back, but its view will be narrower and later. Voyager 1's portrait remains unique, irreplaceable, a frozen instant when humanity chose to look back before stepping into the dark. The golden record still rides with it, carrying sounds, music, and greetings in 55 languages, a time capsule meant for any finder millions of years from now. But the images are different. They are not for aliens. They were taken for us. A deliberate mirror held up at the exact moment we left home.